Okay, so I'm going to teach you how to do the cyclic redundancy check. This one is basically just a concept to, it allows us to find errors in our messages whenever we send them. And it's really simple to implement, so let's just do it. So basically you have a message, which is this guy over here, this big guy over here. So we're going to write the message. So it's going to be 1, 0, and then 1, 0, 1, 0, 1, 0, so 3 more 1 zeros. And then we're basically going to do a division. Now, what we're going to divide through is quite simply, we take our polynomial divisor, which is this guy, and we're going to write wherever other powers that we're missing. For example, we're missing the 2 here, so I'm going to write 0x2 plus x plus 1. Wherever you have a 0, you're going to write a 0, and whenever you have like x's or 1, you're going to write 1. So here 1, here 0, here 1, and here 1. So we have that we can write it here, 1, 0, 1, 1. And now we're almost done. However, what we want to do is we want to add a certain amount of zeros to our message. This is this is determined by the length of this divisor, which in this case is a length of 4. However, we're going to subtract 1, so we get 3. So you're going to add 3 zeros up until the end. So you add the 3 zeros. Let me just move this a bit more to the side so we have more space. Now, what you're going to do is you're going to count 4 digits to the left. So we have 4 digits here. You're going to do 4 digits here. It doesn't matter if they don't fit as long as it's 4 digits. So we're going to do that. And now we're going to do here. Normally, in the normal division, we would have to convert this into second complement. However, this is not the case. We're just going to use the XOR operation, meaning that if we have 1, 0 and 1, 1, then it's going to be just 1. If we have a pair of whatever, then it's going to be 0, 0, and 0. You know what I mean? It's an XOR operation, meaning that if we have an even number of 1s, an even number of 1s in this case is going to be 0, and an odd number of 1s in this case, because we have 1, is going to be just 1. So we're going to continue. We're going to put down a number here. I'm going to put a number down here. It doesn't fit, so 0. Here, 0, and then here it does fit, so we're going to write 1 again. We're going to do our XOR operation. So it's going to be 1, 1, and 0. Then we put a 0 here, another 1, 1, 0, 1, 1. We're going to do 1, 1, 1, 0, and 0, and again 1. And we're going to do 1, 0, 1, 1. And we keep going. So 1, 0, 1, 0. I'm going to add another 0. Let me just copy this because it takes a bunch of time whenever I have to write it. Let's be honest with myself. So just keep going here. 1, 0, 0, 0. And then that was basically, well, let me think what I did wrong. This guy is for this guy. This one is for this one, so we're going to write 1. And then this one's going to be just 0. What we care about is not this number. Rather, we care about the remainder we get. So in this case, we have this remainder. And the remainder we're going to just add to our message. So remember those 3 zeros we added? We're going to take the last 3 numbers of a remainder, and we're going to add it to our message. So the actual message we're going to send is going to be, 1, 0, 1, 0, 1, 0, 1, 0. The actual message to be sent is going to be this. This is our CRC in a sense. This is a CRC part that we just determined. And how this works is, I'll show you. If we go to my example here, and we go down, 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 down to the already written solution, basically, hold on, I'm just trying to find it here. Here, For example, we first did our division and we have the number we want to send, which is this, with our added CRC. However, and when we send this message and we divide it by the polynomial, we get a remainder of 0 in this case. And once we get the remainder of 0, it means it's correct. The message was sent correctly, you can see. However, what happens if we send a wrong message? For example, in this case, we have 0, 1, 1 in this case, which is faulty, it should be 0. If we divide it by the same polynomial, we get a remainder, meaning that we have an error in our message. And this is pretty much it for CRC. So yeah.